Hi there guys, welcome to question 10 where we've got this curve here and we're told that that is this. And yeah, we've got the origin here, we've got this point P, and we have to just show that O to P, so that's this line, that's a straight line there, that line squared is equal to this. So immediately what you should be looking at is dropping a perpendicular here and start to think about triangles. It's got this length squared. It's gonna come in with Pythagoras' theorem. But you might get to a bit of a dead end at the start. And actually, what you want to do is go back to your real basics at GCSE level, even below that. So if you took the graph, say y equals 2x, and let's say I told you what x is, it's 3. You say, well, the y coordinate here is 2 times the x coordinate, and you'd say 6. So we're going to use that sort of knowledge for this. So we can say that P is obviously xy. We're told that in the question. But we don't know what x is. But we do know how to find y, because it tells us here. The y coordinate is 5 take away half of the x coordinate squared. So instead of writing y, we can just swap it for that. So here I could have wrote, like if this is x, this one is just 2x. So here I can write y equals 5 minus half x squared. Okay, so let's go back to this picture, and if we think about it, that there is x, and this length here would normally be y, but we know that is 5 minus half x squared. Now we can use Pythagoras' theorem, and hopefully it gives us this. So let's write that down. Okay, so OP squared is going to be x squared plus 5 minus half x squared squared. Okay, I'm going to write this out in full because when there's fractions, I like to be safe, and I'm going to just change it to be this. It's definitely going to make my multiplication so much easier. Okay, so that's going to be x squared there. First terms, 25. I'm going to combine these next two, so I'm going to have minus 5x squared over 2. Take away another 5 of those. If you just think for a minute, so if we've got that, take away that again, the denominators, sorry, that's an x squared there, the denominators are the same, so we're actually going to get minus 10 x squared over 2, which is the same as minus 5 x squared. And if we multiply these together, we're going to get x to the power 4 over 4. I'm just going to get rid of that working down there. So, looking at this question up here at part A, we've got a quarter of x to the 4. We've got some square terms. Hopefully they will collect to get this, and we've got the 25. And yes, they do. So let's put it in the same order. So we've got a quarter of x to the power 4. 1 x squared, take away the 5 is minus 4x squared. And we've got the plus 25. So it's quite hard actually to start that one and think about doing this. But once you've seen it now, that should make sense if it comes up in the future. Okay, so part B. So part A is done. So part B, this question kind of starts all over again, really. If you couldn't do A, it doesn't really matter. You can do B. It just says find the derivative and find those values of x. So let's do that. So what I'm actually going to use mine. Well, actually, they're exactly the same. So let's find f dash of x. So 4 times a quarter, that's 1. So it's going to be x cubed minus 8x. And there we go. That's it. And we're told it's going to be equal to 0. So let's rewrite that equal to 0. Now I can see here that I've got I can factorize. I can take x outside. So it's going to give me x squared minus 8, and that's going to be equal to 0. So I can get some solutions here. I can say that split these equations up, so x is equal to 0, and x squared minus 8 is equal to 0. Therefore x squared must be equal to 8. And we can square root that, and that would give us 2 root 2's. Please remember that is also minus 2 root 2's, because every square root has a positive and a negative value. Okay, but we can kind of ignore this one because we're talking about a length, so we're not going to have a negative value, and it also can't be 0 either. So this is the one we're going to use. So find this minimum distance. So we've done B, so let's do C. And let's pop it into our formula. So let's pop it into this bit. Okay, so the function of x. So it's going to be the function of 2 root 2's. So that's going to be our x value. So it's going to be a quarter. I'm going to do something a bit sneaky here. Because that's x to the power 4, that's the same as x squared squared. And it's just going to make it so much easier if you use this rather than like putting that to the power of 4. So, and it works for that reason. So what I can say is, well, if x squared is 8, I can just do that, because x squared squared is x to the power of 4. That's the same thing. It's just going to make the math so much easier, especially for this next bit, because it's 4 lots of x squared. We know x squared is equal to 8. And if you haven't noticed that it doesn't really matter, you have your calculator, so you can just type it straight in. But I'm trying to show you here that all of these questions pretty much can be done without a calculator. So 8 squared is 64. 64 divided by 4, well, that's 16. Take away 32 plus 25. And that's equal to 9. So what we can say there is that OP squared, because they are equal to each other, that OP squared must be equal to 9, and therefore OP must be equal to 3. Are there any units? No. Let's leave it as that. And I suppose this bit is quite easy to miss. We also have to show that your answer is a minimum. So we've got to put the derivative equal to 0. Oh, we've already done that, sorry. If we're going to show it's a minimum, let's find the second derivative. So let's find f dash dash of x. You can put f2 there if you want to, but most people do it like this. Okay, so we're going to differentiate this again. So we're going to get 3x squared minus 8. Let's test it for that value of x that we're interested in. But again, I'm going to use this one because I've got x squared and I've got a. It's just so much easier. So that let's write that. So when x is 2 root 2's, that's going to be 3 lots of 8 minus 8. 24 take away 8, well, that's 16. And we can say, I'm just going to squeeze it in this space here. Well, 16 is more than 0. So, oh, it's not D, is it? So it's f dash dash x is greater than 0, and therefore it is a minimum. If you do struggle to remember why that's a minimum, just always think, at this point it's 0. Sorry, that's a maximum. There we go up here. At this point it's a minimum. As we go around this minimum point, the gradients are now becoming negative. They're below 0. So do the sketch each time if you need to.